Okay, hi everyone. Welcome to 441, Secure and Intelligent Programming. This is the second week. I'll give you a lecture about reading articles, some standard published from National Institute of Standard and Technologies. What actually I want to share with you 4 articles, so I wanted to read those. This slide summarize a little bit of those. So I am telling you guide you how you can read, so that another homework assignments is for you to find something from these articles. Okay. Basically, the cybersecurity framework, the core framework consists of functions, categories, and subcategories. That the functionalities of a cybersecurity framework is governing, identifying, protecting, detecting, responding, and recovering. So I explained here governing the organizer's cybersecurity risk management strategy and expectations and policy are established, communication and monitoring. Another function of a cybersecurity framework is identifications. How to identify. The organization's current cybersecurity risks are understood. Understanding the organization's asset, for example, data, hardware, software, systems, facilities, services, people. So organization has asset, supplier, and related cybersecurity risk that enables an organization to prioritize its efforts consistent with its risk management strategy and mission is identified under govern. And the next one is protect. Safeguard to manage the organization's cybersecurity risks are used. So once assets and risks are identified above here and prioritized, protect supports the ability to secure those assets to prevent or lower the likelihood and impact of adverse cybersecurity events, and as well as increase the likelihood and impact of taking advantages of opportunities. This followed by detect. Possible security attacks and compromises are found and analyzed. Detect enables timely discovery and analysis of anomalies, if exist, indicators of compromise, and other potentially adverse events that may indicate that cybersecurity attacks and incidents are occurring. And then finally, we can respond and recover. All right. With that articles can be found. Those articles are also attached so that you can read the real articles. This is about that articles. Okay. Published February 26, 2024 from NIST. So I wanted to read some of those. This is what I explained to you. And functions, the governs all of these phases from identify, protect, detect, response, recover, identify in this cycle. And steps for creating and using cybersecurity framework is to scope the organizational profile, gather needed information, create the organizational profile, analyze gaps, and create an action plan. And then finally, implement action plan and update the profile. And we repeat this, every steps of those. Okay. And the next article is something about the cybersecurity development framework that you can find from this article. Published in 2022, and executive summaries, then table of content. Introductions explains why you need SSDF. But actually there is a software development life cycle. But now secure software is important. So we can think of also secure software development lifecycle. This is a software lifecycle, software development lifecycle, right? Waterfall type of software development cycles. So we can start from this top. So requirement analysis, like water can falling. And the next one is the system design, implementation, testing, deployment, and maintenance. For each steps, you can also going back from here. Well, actually, this should go. Yeah, arrow should go down. So go back to the requirements, implementation. While you are doing implementation, if you have any issue for design, then go back to design, or even further the requirements. Similarly, here's spiral models. Okay, that type of things. So stakeholders of secure software practice are business owner, of course. Business owner that decided to deploy software packages, and then the owner can make further additional decisions. Or software consumer, or software producer. So three stakeholders needs to work together. If we have some issue found from business side, then we need to improve that, or we need to correct any errors from the products. Then we need to go back to the software producer. Well, at the consumer side, consumer may be able to see some of the issues, some cyber threats or some vulnerabilities of the software, then can come to the business owner, or you can report back to the software production side as well. So with those stakeholders, we can consider organization, software, and vulnerabilities. POPS, PW, and RV. So prepare the organizations. This is a long list of the table that you can see. Yeah, this is those things, right? So this is a secure software development framework. Prepare organizations. So you can define security requirements for software developments. For this preparation practice, there are a number of tasks. To do this, you need to identify and document all security requirements of the organization's software development infrastructure and the processes, and maintain the requirements over time. In addition to this task, there's another task also considered. Identify and document all security requirements for organization develop the software to meet and maintain the requirements over time. PO 1.3, communicate requirements to all third parties who will provide commercial software components to the organizations for reuse by the organization's own software. So this, the column is for the practice, and next column is for the list of tasks, and then examples. For this, what kind of examples then you can think of? Okay, some of the examples. And then fourth column gives you the reference. If you want to see more reference, for example, OWASP, some of this, then if you click this and it goes to that the references. If you want to get real articles, for example, this, then go to the WASP, open from the Google, and therefore you may be able to see this kind of the articles and softwares. This is actually software, right? So this is very, very useful documents that you need to read. From this tables, right? So lots of the first column is for respond practice. Others is for example, configure the compilation interpreter and build the process to improve executable security. For this practice, the tasks that we need to consider is user compiler interpreter. This is like the language compiler, language interpreter. Like Python is an interpreter, C is a compiler, Java is again that is could be a compiler, could be interpreter, and the build tools that offer features to improve executable security. Another task for this configure the compilation interpreter is to determine which compiler, interpreter, and build tools features should be used and how each such should be configured, and then implement and use the approved configurations. Example for that, use up-to-date version of a compiler, interpreter, and build tools. Another example is follow change management processes when deploying or updating compiler, interpreter, and build tools, and audit all unexpected changes to tools. Regularly validate the authentication and integrity of a compiler, interpreter, and then build tools. So also see PO3. If you go PO3, then specify which tools and tool types must or should be included in each tool chain to mitigate identified risk, as well as how the tool chain components are to be integrated with each other. Okay, so this article's little bit of introduced on this slide from preparations of organization, protection of software, protection of well-secured software, and respond to the vulnerabilities. So all those tasks are found from that articles, SSDF articles, Secure Software Development Framework. More that you can read, that is something about software supply chain, so-called SSC. So what is SSC? SSC means, you know, we since COVID-19, we had really big threats from supply chain issues, right? Because we heavily, for example, America markets heavily dependent on the Chinese producers. During COVID-19, China didn't send the supplies to us. Therefore, we have shortages. I wanted to recall, for example, a face mask. From that pandemic, because we do not have face mask, then it's very hard for us to protect from any infections, any virus attack, right? There's a supply chain issues. That things really the threats in our real world. But in the cybersecurity, for example, software has also supply chain issues. Software needs to be updated and improved if there is any threat, any vulnerabilities, then that software needs to um, correct that the security vulnerabilities in the next version of software developments. So there is a somehow software development, software supply chains. So one of the main things is that when new version of software released, and therefore if we purchase it, then therefore our current software systems still needs to be functional, right? So we need to consider continuous integrations, integrate with the new versions. And the new one small components of the software, if it is updated and therefore deployed, as it was well communicated with the other components, it should be nicely integrated with the legacy systems and continuous deployments. So CI/CD, which means continuous integration and continuous developments, that is the issue, right? That those things are considered, and that is here in this article. All details are described, written about a year ago, right? So all of these are brand new, the concepts. So you can read the articles, another similar articles related with that supply chain. Then if it is a software supply chain, then we need to think of cybersecurity supply chain risk management. Okay, those things are discussed in the articles. I want you to read those, and then do the small homework assignments. Homework assignments will be posted. All right. So this is a short response of the second module of this class. Okay. I'll see you the next time. Thank you.